So we're going to solve some more trig equations. So we're going to start with 1 plus sine theta equals to 2 cosine squared theta. Well, if we want to solve this, we have to have all of one trig function, not multiples of them. So we're going to use our trig identities to do this one. So we're looking at 1 plus sine theta we're good on. But I need to write cosine in terms of sine, so I have one identity. We've talked about this multiple times, that cosine squared theta is going to be equal to 1 minus sine squared theta, using our Pythagorean identity. So now we have 1 plus sine theta. We're going to distribute. 2 times 1 is 2. 2 times negative sine squared theta will be minus 2 sine squared theta. And now I'm going to do some algebra here. I'm just going to add or subtract, whichever way they are, move everything to one side. And just like in algebra, I want to make my squared term positive, so I'm moving everything to this side. So now I have 2 sine squared theta plus sine theta, and 1 minus 2 will get us negative 1 equal to 0. So again, you can factor this using the signs, or you can do it with the x's. Either way you want to go. So I'm going to factor this one with the signs. I did the one in the last section using x's, and I'll also show you the x's. So we're still using the a times c gets you to b method, the AC method. So 2 times negative 1 gets me negative 2, and I'm trying to get to a 1. So if I do 1 and 2, because 1 times 2 will get me 2, I need the bigger number to be positive. So negative 1 times 2 gets me negative 2. When I add them, I get 1, and that's what I'm looking for. So now I can rewrite that term using negative 1 and 2. So we'll have 2 sine squared theta minus sine theta plus 2 sine theta minus 1 equals 0. And then I'm going to do just like I normally would. I have 4 terms. I'm going to factor by grouping. I can factor out a sine theta and get 2 sine theta minus 1. Bring down my plus sign. Over here, there's nothing I can factor except a 1. So plus 1 times 2 sine theta minus 1. And if you notice, I have the same thing in my parentheses. So it works just like when we're doing x squareds. So now I have 2 sine theta minus 1 times sine theta plus 1 is equal to 0. Now, if you really don't want to use the sine parts, you can come over and use the x instead. So you'd have 2x squared plus x minus 1 is equal to 0. You're going to get the same 2 times negative 1, same 1 value, so now you'd still rewrite it. You'd get 2x squared minus x plus 2x minus 1 equals 0. You're still going to split it in half. I can factor out an x and get 2x minus 1 plus 1 times 2x minus 1. Notice how they match still. So I have 2x minus 1 times x plus 1 equal to 0. Oh, and then you substitute back in for sine theta. So you can do it either way. It doesn't matter. You're going to get the same thing. And again, it doesn't matter if you put this one first or if you put this one first. Alrighty. I do it that way because I'm factoring out a common factor. But it doesn't matter either way. So now what we're going to do is take each part, set it equal to 0. So sine theta minus 1 equals 0, and sine theta plus 1 equals 0. So we'll add our 1 over. We get 2 sine theta equals 1. Divide by 2, and sine theta equals 1/2. And here we'll subtract our 1, and sine theta equals negative 1. So now we need to know what angles work for this. So for 1/2, we know that when sine theta equals 1/2, we have theta is equal to pi over 6, and theta is equal to 5 pi over 6. That's our quadrant 1 and our quadrant 2 where sine is both positive. And for this one, this is going to be -1 when we're down here on our unit circle. It's that y-intercept where it equals -1. So this will be theta is equal to 3 pi over 2. Now remember, we're looking at our period of 2 pi because we're looking at sine. And sine has a period of 2 pi. So for all of our solutions, we are looking at theta is equal to pi over 6 plus 2k pi. Theta is equal to 5 pi over 6 plus 2k pi. And theta is equal to 3 pi over 2 plus 2k pi. And of course, for k is any integer. All right, so let's go look at another example. So if we want to solve sine of 2 theta minus our cosine theta is equal to 0. So in solving this, we're using the formulas that we have learned. We know that 2 theta is a double angle, and so we are looking at using our double angle formula for sine of 2 theta. So that's going to get us 2 sine theta cosine theta minus our cosine theta equal to 0. Now, between those, I can look for a common factor of cosine theta. So cosine theta times 2 sine theta minus 1 is equal to 0. Set each part equal to 0. And we're going to end up with the cosine of theta is equal to 0. We're solved there. Here we're going to add our 1 over and get 2 sine theta equal 1, divide by 2. So we end up with sine theta is equal to 1/2. So now we're looking at where all of our angles are. So for cosine theta equal to 0, we're going to have theta is equal to pi over 2, and theta is equal to 3 pi over 2. For sine theta equals 1/2, we get theta is equal to pi over 6, and theta is equal to 5 pi over 6. And this is in the interval of 0 to 2 pi. So for all of our solutions, we have theta equals pi over 2 plus 2k pi. Theta equals 3 pi over 2 plus 2k pi. Theta equals pi over 6 plus 2k pi. Theta equals 5 pi over 6 plus 2k pi. And of course, k is any integer. So in this case, we had 4 angles plus our 2k pi where they're going to land. All right, so let's go look at another example. So we want to solve cosine theta plus 1 equal to sine theta. And of course, we're looking at 0 to 2 pi because that's where our cosine and sine are. Well, there's not much we can do here, but we're going to use some things that we know from algebra. We could square both sides, so let's do that. So over here, we end up with cosine theta plus 1 squared. So that's cosine theta plus 1 times cosine theta plus 1. You multiply them together. So we're going to end up, when you multiply that, as cosine squared theta plus 2 cosine theta plus 1. So that's foiling this twice. And this is going to be equal to sine squared theta. Well, in order to solve this, I have to have all one term, one function. So I'm going to change my sine squared theta. So we've got cosine squared theta plus 2 cosine theta plus 1 equals 1 minus cosine squared theta, because that's what sine squared theta equals. So let's add this, or move this to the other side with addition and subtraction. So I'm putting them under their common terms, so it'll be easier to add them. So now I have 2 cosine squared theta plus 2 cosine theta. My 1's will cancel, and that equals 0. So now I'm going to factor out a 2 and a cosine theta. So 2 cosine theta times cosine theta plus 1. So I just factored out 2 cosine theta out of each one is equal to 0. So now we have 2 cosine theta divided by 2. 2 cosine theta is equal to 0. I need to divide both sides by 2. And I get cosine theta equals 0. And then this part, I have cosine theta plus 1 equals to 0. So cosine theta will be equal to negative 1 when I move that over. So cosine theta equals to 0. That'll get me theta equals pi over 2. And theta will equal 3 pi over 2 at the y-intercepts. Cosine theta equals negative 1 is over on that x-intercept, where our theta is equal to pi. But we have to remember that when we square both sides, we have to look for weird answers. So we've got to double check this. So I'm going to do the checking right over here, so we're on the same page here. So we need to look at theta is equal to pi over 2. Well, if I go back to my original equation, I'm going to get the cosine of pi over 2 plus 1 is equal to the sine of pi over 2. Well, cosine of pi over 2, that's going to be 0 plus 1. Sine of pi over 2 is equal to 1. Well, we get 1 equals 1, so this one works. If we look at theta is equal to 3 pi over 2, we get the change colors so they're not running together. We get the cosine of 3 pi over 2 plus 1 equals the sine of 3 pi over 2. So cosine of 3 pi over 2 is going to be 0, and the sine of 3 pi over 2 actually equals negative 1. So we end up with 1 equals negative 1, and that is not true. All right, we have one more to try, and that is for theta equals pi. So now we have the cosine of pi plus 1 is equal to the sine of pi. So at pi, cosine of pi is going to be equal to negative 1 plus 1, and the sine of pi is equal to 0. Well, negative 1 plus 1 is 0, so this one is also true. So for all of our solutions, we will get theta is equal to our pi over 2 plus 2k pi, and we'll get theta is equal to pi plus 2k pi, and of course k is any integer. So that would be for all of our solutions after we have ruled out what worked and what didn't work. All right, so let's go on to our next example. So you have to be aware of those erroneous solutions when you square things. So for the next example, we are going to solve 2 sine 3 theta minus 1 is equal to 0. So we are going to divide by 2, or add our 1 over first. So 2 sine of 3 theta equals 1. And then we'll divide by 2. So our sine of 3 theta equals 1/2. Now we've done this sine many times. We have a little bit different happening here. So we know that 3 theta is going to be equal to pi over 6, and 3 theta equals 5 pi over 6. The difference is we didn't get theta this time. We have 3 theta. So we're going to have to divide both by 3. So let's bring these up here. So we'll have 3 theta is equal to pi over 6 plus 2k pi. Well, we got to get a common denominator. So this is over 1, so we're going to have to get it over 6. So this would be equal to, oh, nope, sorry. First we got to divide by 3. Let's divide by 3. So if I divide both of them by 3, I now have theta is equal to pi over 6 divided by 3. Well, we don't divide by fractions, we multiply by reciprocals. So we'll actually multiply by 1/3, so we'll get pi over 18. And we have 2k pi over 3, but I need it to be the same denominator. So I need this to be 18 as well. So I multiplied 3 times 6 to get to 18, so 2 times 6 will get me 12. So this is one of my solutions. The other solution we're going to find right here is that we have 3 theta is equal to 5 pi over 6 plus 2k pi. Again, we're going to have to divide everybody by 3. So theta, don't divide by the fraction of 3. You can look at that as 3 over 1. We multiply by 1/3, so we'll get 5 pi over 18 plus 2k pi over 3 is still going to become 12k pi over 18, just like we did here. We're multiplying both the top and the bottom by 6. And of course, in all of these, k is any integer. And this applies to both this one and that one. So, we are looking for our solutions in 2 pi, because that is what our for sine, we have a period of 2 pi, but we actually had an angle of 3 theta. So we are looking for our pi. We need to find the solutions that are from 0 to 2 pi. And we're looking at, because we have that 3 theta, instead of just being 2 pi, we're looking for the solutions in 0 to 2 pi. And with that 0 to 2 pi, we are looking for 0. But I need to get that common denominator is what I need. So I'm looking at for 18, because I have to add 12k pi over 18. So I want 2 pi to be the 18s, because that way I can see where my 2 pi ends. So remember, this is 2 pi over 1. I multiply by 18 on the bottom. I have to multiply 18 on the top. So that'll get me 36 pi over 18. That's the same thing as 2 pi. And that'll help me know when I need to stop. So we're going to find all of the actual values by plugging in our k's until we hit the stopping point. So we're going to go pick some solutions for the answer to this. Instead of just saying, well, it's going to be all of those, let's go actually find the answers. So we are looking at k is equal to 1. So for k is equal to 1, we're using this equation here and this equation there. We're going to have theta is equal to pi over 18 plus 12 times 1 pi over 18. So I'm taking that equation and I'm plugging in 1. And then I'm also going to plug it into this one over here. So this will be theta is equal to 5 pi over 18 plus 12 times 1 pi over 18. Well, with 1, it doesn't change at all. So pi plus 12 pi, oh, I forgot to do k is equal to 0. So sorry about that. All right, let's just slide in a new page here. We forgot to do the 0, so let's start with 0. So we're going to start with k is equal to 0. Same thing's going to happen. Theta is equal to pi over 18 plus 12 times 0 pi over 18. So this will become 0 divided by 18, which is just 0. So we'll end up with pi over 18. So that's one of our angles. We'll draw our line again. We'll have theta is equal to 5 pi over 18 plus 12 times 0 pi over 18. Again, this becomes 0, so we end up with 5 pi over 18. So there's two of the places where we have what theta will be. All right, now let's go to k is equal to 1. So theta is equal to pi over 18 plus 12 times 1 pi over 18. Well, the 1 isn't going to change the number. It'll still be 12. So 12 plus 1 will get us 13 pi over 18. Same thing will happen over here. We'll have 5 pi over 18 plus 12 times 1 pi over 18. So 12 plus 5 will get us 17 pi over 18. All right, let's go look at k equal to 2. So here we have theta is equal to pi over 18 plus 12 times 2 pi over 18. Well, this changes a little bit, so I'm going to do a little bit more work here. I get pi over 18 plus 12 times 2 is 24 pi over 18, and that gets us 25 pi over 18. Over here, we get theta is equal to 5 pi over 18 plus 12 times 2 pi over 18. Well, that gets us 5 pi over 18 plus 24 pi over 18. That'll get us 29 pi over 18. Now, remember, we have to stop at 36. 36 is when we're done, 36 pi over 18, because that's 2 pi. If we notice, this is jumping up here by 12 and by 12. If I add 12 to this, that's the difference, it's going to get me to 37 pi over 18, and that will be too far. So those will be the angles that we hit. We can't do another one because we'll be past our period of 2 pi. So that's where you would stop on that one. All righty. So we are going to go look at another example. We're going to look at solving the square root of 3 times tangent let me think about this for a second. Yeah, we'll go ahead and do this one. So theta divided by 2 minus 1 equals 0. All right, so the square root of 3 plus tangent of theta divided by 2. I want to get that square root of 3 gone. So square root of 3. Oh, I forgot to move the 1 first. I can tell my brain is getting tired. Let's add our 1 over first. So square root of 3 of tangent theta divided by 2 is equal to 1. We're just using our algebra skills here. Divide by the square root of 3, so the tangent of theta divided by 2 equals 1 over the square root of 3. So if we're looking at the solutions, we are now looking at the fact that we have theta divided by 2 is equal to 1 over the square root of 3. So where does our tangent equal 1 over that square root of 3. Well, that's going to happen at pi over 6. And again, this is by knowing our unit circle. So the tangent of period is equal to pi, and we're looking at unit circle. That's what we would get, is at pi over 6. So we can have the theta over 2 is equal to pi over 6 plus k pi, because it's not going to be 2k pi. But I want to know what theta is, so I'm going to multiply both sides by 2. We're not squaring, we're multiplying by 2. So here we'll get theta, and here we'll get 2 pi over 6 plus 2k pi. We'll reduce this down to get theta is equal to pi over 3 plus 2k pi. But I need that common denominator again, so my theta will be equal to pi over 3 plus, this will become 6k pi over 3. Common denominator, remember this is over 1, multiply by 3 on the bottom, multiply by 3 on the top. So now that we have this, and of course k is going to be any integer, so that's our general solutions. We want to find all solutions in 0 to 4 pi. So I'm going to solve that right over here. So we want all solutions in 0 to 4 pi. So we're looking at 0 to 12 pi, because we need to get that common denominator again of 3. All right, so if I want this to be equivalent, this will get me, and I believe this is going to be this way. It'll be 0 to common denominator 12 pi over 3. All right, so that's all of our solutions. And that is what we need to find. So we're going to start again with k is equal to 0. So we're looking at theta will be equal to pi over 3 plus 6 times 0 pi over 3. And that, of course, will be 0, so we'll get pi over 3. So the next one, we'll do k is equal to 1. So theta is equal to pi over 3 plus 6 times 1 pi over 3. That's going to get us 6 plus 1, that is 7 pi over 3. So we're still good, we haven't reached the 12. But if you notice, we went up by 6. If I do the next one, if I do 2, I'll have 1 pi and I'll have 12 pi. 6 times 2 would get me 12. That'll get me past, because I'll have 13. Pi over 3. So that's too many, so this is where we would have to stop. So when you have to translate those in, you just have to be aware of translating this to a common denominator. It gets you an idea of when to stop with your values of your theta.